My name is Sean Curtis Patrick, and I'm the Media Design and Production Lead at the Center for Academic Innovation at the University of Michigan. In the summer of 2019, I was on assignment to Greenland. My main duty was to be the expedition's videographer, but I did have another objective in mind. That was to create a high-resolution 3D model of a glacial calving front utilizing drones. The closest thing I had ever seen to this experiment being conducted before was something done by NASA a few years ago, but it was fairly low resolution as it was shot from airplanes at altitude. This would be completely different though. It would be a high-resolution 3D model shot with photogrammetry via drones and onboard sensors. The first time we attempted this experiment, the drone, which we had named Sparky, went completely haywire. The drone zipped off in the opposite direction of us into the interior of the ice sheet at about 45 miles an hour until it was just a speck on the horizon. Through entering a few manual emergency modes, we were able to land the drone manually, but we did lose that map. It would be an experiment for another day. The next day we attempted the mapping again, but upon a short warm-up session, the drone crashed at maximum power. We were able to figure out it had something to do with magnetic calibration due to the high latitude we were at. Sparky was obliterated on impact, but some of the students recovered Sparky and we were able to tape it back together and it was able to fly the remainder of the day before it died completely. The crash rattled the team and I began wondering if this experiment would happen at all. Thankfully, we had two other drones with us, which we had named Cicada and Wolverine. We gave the mapping a break for a few days and did other things. We chased a weather balloon with the drone, getting some very interesting perspectives that probably haven't been seen before, as well as attached a small bank of sensors to the underside of the drone and flew it over the ice sheet. But after a few days, we decided to give it another shot, this time at a place with zero obstructions, at the top of a mountain called Mount Evans. This is where the 1926 to 1928 expedition from the university set up and conducted many experiments. Few people have been to the top of Mount Evans since that original team left. We did our best to map the space in 3D from an archaeological site perspective. This test was very successful and emboldened us on trying the glacier once again. After charging a few batteries, we departed for the glacier for the very last time. We were leaving the next day, so this shot really needed to count. I feel so good. It only took, a $2,000 drone to be lost and a few days of terror, but it's finally mapping. It's finally doing it. So this should, if all goes according to plan, give us a 3D map of this calving front. This experiment has been very successful. Glaciers are so alive and ever-evolving, and to see these spires or giant house-sized blocks change from day to day was such an amazing and rewarding experience. It'd be really cool to try this experiment again, refining all the techniques that we created over those first 10 days. I hope this first attempt inspires others to give it a shot. I can't wait to see their results.